Alright, so in this video, we will take a look at the level 3 questions, the harder questions that I can ask you with respect to special product of algebraic expression. So before we look at the questions itself, let us recap back. So we have three special products, remember? We have a plus b the whole thing square is equals to a square plus 2ab plus b square. And then we have a minus b the whole thing square, so a minus b the whole thing square is equals to a square minus 2ab plus b square. Okay, and then we have the last one, your a plus b, a minus b. So a plus b, a minus b is equals to a square minus b square. Okay, so these are the three special products. Now let's take a look at your question in level 3. So in question level 3, you have to rewrite each of the following as a special product of algebraic expressions and evaluate it. And then they give you a number 198 square. How is that algebraic? Okay, now just a few background or a few historical story to tell you guys as to the usage or rather why this is so important, especially in the past. In the past itself, there was no calculator. Okay, so all the calculations had to be done paper and pen or by mental sums. And in this case, if I want to square 198 square itself, you realize that there's a few issue here because of the fact that 198 square is so hard to multiply itself. Remember, if let's say you want to do this by primary school method, you have to take 198 times 198. It's so hard. Okay, that's three digits. Okay, so this, of course, was not a viable method. So what they do is they make use of these algebraic products, okay, to help us solve this or make this into an easier thing to solve. Okay, so let's look at this question. How can we do it? So we have 198 square. Now the closest number that's easy to square is 200. So I can easily put this as 200, and then to get 198, I'll just minus 2. Okay, so 200 minus 2 square. Okay, 200 is a number that's easy to square. 2 is also a number that's easy to square. And you realize that, hey, this looks exactly like this form over here. This whole thing looks like a minus b the whole thing square. So what I can do is I can expand this. Okay, so if I expand this, I will have a square minus 2ab plus b square. And your a is 200, your b is 2, so 200 is a, and your b is 2, so 2. Okay, so expanding this, I will have 40,000. So 200 is 40,000. So how do I expand this? 200 square is 2 times 2 is 4. Then I have two zeros, so because it's square, I have added two more zeros. Minus 2 times 200 times 2, so minus 406 minus 800 plus 4. And this becomes a very simple sum to do mentally. So 40,000 minus 800 will get me 39,200 plus 4 is 39,204. So look, it's so easy to do this without even doing the long method itself. You can actually do this mentally even. All right, now let's take a look at the next one, 30.5 square. So 30.5 square, you realize that, hey, this is even worse than the first one. At least the first one was a number. Here I have a, at least the first one was a integer, okay, a whole number. Now I even have a decimal number, 30.5 times 30.5. Okay, imagine if this came out for your primary school questions, you will be like, how am I supposed to do? Okay, so what I will do is I'll put 30.5 square. So the nearest number that's easy to calculate is simply 30. And then to get 0.5, so I have 30 plus 0.5, the whole thing square. Now 0.5 might not look so easy to calculate, but if I change 0.5 to a fraction, so instead of 0.5, I can change this to half. So instead of 0.5, let's change this to half. Because half a fraction is easier to calculate in terms of mental sums, I guess. Okay, so I have, oops, 30 plus half square itself. All right, so this you realize Hey, it looks exactly like my a plus b the whole thing square. So let's expand this using your algebraic product. So I have a square plus 2ab plus b square. So a is 30 and b is 0.5, which is half. So you realize that I have 30 square. 30 times 30 is simply 900. 2 times 30 times half. So 2 times half is 1. You can cancel out the 2. So this cancel. I'm left with 30 alone. And half square. So the square will go to both 1 and 2. So I have a plus 1 over 4. So if I simplify this, okay, I will simply get 930 1 over 4. And 1 over 4 is simply 0.75. So 930.75. So I don't even have to use a calculator to do this. Alright. So let's take a look at the last question. I have 99 times 101. Again, although they are integers, but 99 times 101, it's so tedious to do. Okay, but you realize that the nearest number to both 99 and 100 is 101 is 100. So you realize that 99 multiplied by 101, okay, is simply 100 minus 1 and 100 plus 1. And this is simply the form of your a minus b, a plus b. So this is your a minus b, your a plus b. And remember, a minus b, a plus b is simply a square plus minus b square. Even easier to calculate. Okay, so what happens is we can put this as a square minus b square. So your a is 100 and your b is 1. So I have a square is 100. So times 100 is 10,000 minus 1. So I have 9,999. Okay, so with this, we have come to the end of this chapter 8.1, special algebraic product uh, itself. All right, so always remember the objective of this is so that you can expand certain algebraic expressions using the special product of uh, special product of algebraic terms without using your multiplication frame. Okay, so it's like a shortcut per se. And of course, I hope that the level 3 questions helps you give a better appreciation to how algebra has helped humans, help us in times where we didn't have the technical advances that we have today. A lot of things that we take for granted wasn't in existence even as late as 50 years ago. There was no calculator in 50 years ago, or the calculator was very big, or not everybody has an access to a calculator. And you realize that, hey, then I need to do a lot of mental sums. So how do I make my sums easier? And that's where your special algebraic products come into play. Okay, so I hope you have achieved two things. You have learned how to expand using special product, and you have gained a better appreciation of how algebra has helped us to calculate easier. All right.